Good day. So in this video, I'm going to illustrate to you how easy functions are. So this is one of the topics that when you come across in the exam, you should get excited because it's quite easy. The answers in most cases, they are on the graph. So I've seen students struggling a lot with functions, mostly because I've seen that they lack understanding. Doing a lot of question papers is good, but if you lack understanding of the topic, no matter how many question papers you do, the moment you get a different question, you'll be off the road. So the purpose of this video is to equip you with understanding, that you understand functions so that you'll be able to answer any kind of a question. So yeah, without wasting much time, I'll be focusing here on the parabola, which is also called the quadratic function. So as you know, the quadratic function here has got a general equation. Y is equal to ax squared plus bx plus a c. Now, if a in the parabola equation or quadratic equation, if your a value is greater than 0, simply means that it is a positive number. So if you think of any number that is greater than 0, that is your likes of 1, 2, 3, that's a positive number. So if a is positive, you should expect automatically a graph that has got a minimum point. So think of it this way. This is like a valley. A valley has got the bottom, which is the minimum point, or also a cup. So a cup has got there is a minimum point. So that is the minimum point. So alternatively, if a is less than 0, it simply means that a is a negative number. So any number that is less than 0, that's the like of -1 and so on. What it means is that that graph, the parabola, will have a maximum point. So this is like a hero, and also it's like a cap. So it will have a maximum point. And also you should be familiar with this kind of shapes of graphs. So the moment you see that graph in an exam, that's a parabola. So then the parabola rules should start kicking in. So that is how the a value illustrates the graph. So a is greater than 0, that's a minimum graph, and a is less than 0, that's a maximum graph. That is the first thing that you need to know about the quadratic functions. Now, since now you know that the general equation of a quadratic graph is y is equal to x squared plus bx plus c, now we want to talk about the key features on a parabola. Okay, so to express that or to explain that, we are going to use an example of the equation y is equal to want a positive graph, y is equal to x squared minus 6x plus a 5. So you can see that here your a is just equal to 1, and your b is equal to -6, and your c is equal to 5. So the key features that we want to talk about is, number 1, your y-intercept. Y-intercept. So the y-intercept, to determine the y-intercept, you let x is equal to 0 in the equation. So like in this equation now, if x is 0, your y will be equal to 0 squared minus 6 times 0 plus a 5. Then your y will automatically be equal to 5. So that's your y-intercept. Okay? Then the next thing that you want to talk about is the x-intercept. So it's called the x-intercept or x-cut, or I want to call these ones the roots. So these are the roots of the equation, because you are letting x is what? In this case, y is 0. So y is equal to 0. So 0 will be equal to x squared minus 6x plus a 5. And then to solve that, you factorize this part and you get x minus 1, bracket, x minus 5. And you know how to solve this? Then x minus 1 is equal to 0, or x minus 5 is equal to 0. Then x is equal to 1, or x is equal to positive 5. That's your x-intercept, or also the roots. So once we have these two things, we can be able to sketch a graph. But before we sketch the graph, one thing that we want to also determine, which is a key feature on the graph, is the turning point. The turning point, where the graphs turn, either a maximum point or a minimum point. So to determine the x-coordinate of a turning point, if you have got an equation like this, if you have this equation here, to determine its turning point of this equation, you just let x is equal to minus b over 2a. That is how you determine the x-coordinate of the turning point of a parabola. So in this case, you know so that will be equal to minus in a bracket minus 6, because that's our b right here, then over 2a, and that's 2 times 1, which is equal to 3. Then if we have our 3 as the x-coordinate, to get the y-coordinate of the turning point, we substitute again back into the equation. Then when you substitute that, you realize that your turning point will be a 3 and negative 4. So these are your key features. Number 1, your y-intercept. You need to be able to determine your y-intercept. And number 2, you need to be able to determine the x-intercept by letting y is equal to 0. And number 3, you need to determine the turning point. And remember, to determine the x-coordinate of a turning point, use the formula x is equal to minus b over 2a, which is equal to a 3. And in this case, to get your y-coordinate, you substitute back into the equation. Then you get your y-coordinate. Now, remember, we are still dealing with the key features on a parabola. So using the same example, remember we say that the y-intercept was 0 and 5. Then the x-intercept, we determined it to be, it was x 1 and 0. And also the other one was 5 and 0. And we determined also the turning point, and that was 3 and negative 4. So once you have all these 3, you can be able to sketch your graph, and you just have your y-axis and the x-axis and your x-intercepts. That's 1 and a 5, and your y-intercept, that is it was a 5, yes, as well. Then your minimum point was 3 and negative 4. So now once you have all these points in order, you can be able to sketch your graph. And there you go. That is the sketch of the graph y is equal to x squared minus 6x plus a 5. Now, while we are on this graph, the other thing that we need to talk about is the domain and range. So the domain, these are your x values. Domain is the x values. So the x values, you should know for a parabola that the domain of a parabola is always x is an element of all real numbers. So what it means that the function can take up any x value and you get an output. So that is your domain. The moment you see a parabola, they ask you for the domain, just say x is an element of all real numbers. Then if they ask for the range, then the range, remember, those are your y values. So how do you determine the range? You always check your turning point. Remember your TP for the range. Your turning point here, it's 3 and negative 4. So the y value for the turning point is negative 4. So you can actually say y, in this case, because your graph is going up, you can see all the values of y are increasing from negative 4. Then you can say y is greater than or equal to negative 4, because 4 is part of the graph. So y is greater than or equal to negative 4. Even if it was a maximum graph, you just check the maximum point, then you say y is less than or equal to. That's how you determine the domain and the range of the parabola. I hope that makes sense, guys. Now, with that in mind, let's look at different ways that they can express the graph or the function of y is equal to ax squared plus bx plus c. There are different ways that they can express this. Now, using our previous example, y is equal to negative 6, not negative, I don't know why I'm liking this negative. Y is equal to x squared minus 6x plus a 5. So I want to show you how to express this equation in different forms. So this equation can also be expressed, number 1, into what we call the turning point format. So the turning point format, it's like y is equal to a bracket x minus p bracket squared plus a q. So if you have got the coordinates of the turning point, that is your P and Q. So P and Q are the coordinates of the turning point. And we have those coordinates. Remember, we said the coordinates of the turning point in this equation was equal to 3 and negative 4. If you're not sure, go back to the previous example that we did. So the turning point is 3 and negative 4. So to illustrate this equation, you just put it in that format here. So you just say y is equal to, in this case, your a. Your a is still 1. So it's just 1. There's no need to write it. Then in a bracket, x minus p. Your p, remember, is the x coordinate of the turning point, and that is a 3. So that is minus 3. Bracket squared plus q. And q is negative 4. So it's actually negative 4. Then you have expressed this equation in the turning point format. This expression is, if you expand it, it just gives you come back to this other original equation. And that is how expressed in the turning point format. The other format that I like to call it the root format. So if you have got the roots, remember we determined the roots of the equation. We said that x was equal to 1 and also x was equal to a 5. So then if you have got the roots, you can express this in the root format, which is y is equal to a bracket x minus root 1. Some they want to just call it x1, but I like root 1. Then x also minus root 2, which is the x2 as well. So to express this, because we have got also x1 and we have got the roots 1 and 5. So you just say y is equal to a, and your a is just 1 again. So in a bracket, x minus root 1 was 1, bracket x minus root 2 was a 5. And there you have it. Two format, that is the turning point and the roots. So what it means is that if you have got the roots of the graph, you can be able to determine the equation of the graph. And if you have got the turning point of the graph, you can be able also to determine the equation of the graph. I hope that makes sense. And let's move into the next section of the quadratic functions. Right. The other thing that they would like you to determine on the parabola is the equation of the axis of symmetry. So the axis of symmetry is just, remember, the line of symmetry is just a line. So if you fold this shape here, it becomes two equal parts. So in this case, with this parabola, in which part would you think we can fold this graph to be two equal parts? And of course, that will be this line here. And you can see that line is actually going to the turning point. So the equation of the axis of symmetry, so it's an equation. So it will always start with x is equal to, because it's cutting through the value of x of 3 here, which is your x coordinate of the turning point. So the equation of the axis of symmetry in this case will just be equal to x is equal to 3. And that is the equation of the axis of symmetry. Guys, this stuff is so easy. So make sure you master this, and then you won't have any problems. Now, moving on to the other section of the quadratic function, the last section. Now, in this last section, we are going to look at how to determine the equation of the parabola. So in this case, you just be given a graph. So one thing that you have to look out for, what are the points that you're given? So in this case, you're given the turning point. So automatically, the turning point formula should kick in, which is TP. Remember, we say that on the turning point, y is equal to a bracket x minus p bracket squared plus q, where your p and q is a turning point. So you simply substitute that. Y is equal to, in this case, you don't know your a. So a bracket x minus 3, because that's your x coordinate of turning point, bracket squared, minus 4, because that's your y coordinate of turning point. Then to get a, because you've got another given point, you don't use the turning point, otherwise it won't work. You use another given point, in this case, that is a 0 and 5. So in this case, y is 5 and x is 0. Then 0 minus 3 bracket squared minus 4. So in this case, you can be able to determine your a value. So if you look at it, that will be now here, if you put that here, 5 minus, so that will be 5 plus 4, that's a 9. Then 9 divided by 9, that's a 1. So your a is actually equal to 1. So then you can write down your final equation. Y is equal to a is 1, bracket x minus 3 squared minus 4. And there you have your equation. Usually these things have got like 3-4 marks, a lot of marks for easy things. So make sure you master this. Now, in another example, you can be given now the roots. Then the root formula should kick in. Remember the root formula? Y is equal to a bracket x minus x1 or root 1 bracket x minus x2 or root 2. So in this case, you've got all your roots. So y is equal to a bracket, the other root is x minus 1 bracket, the other root is x minus 5 bracket. Then to get your a, use again another different given point. So in this case, it's a 0 and 5 as well. So 5 is equal to a bracket x. Actually, the value of x here, it's given, and that's your 0. So 0 minus 1 bracket, 0 minus 5 bracket. Then you get that again, your a is equal to 1. Then you write down the final equation. Y will be equal to a bracket, not a, it's 1. So we don't need to write 1. So it's just bracket, y is equal to bracket, x minus 1 bracket x minus 5. And there you go. You have got all your equations. So sometimes they ask you, oh, put it in the format y is equal to ax squared plus bx plus c. What you simply do, you expand this thing, this equation, and you just expand that equation. And that's how you determine it in the form ax squared plus bx plus c. I hope that makes sense, guys. So in summary, what did we learn about? Number one, we learned about that the equation of a parabola is expressed as ax squared plus bx plus a c. And this equation can be expressed in the format of the turning point, which is y is equal to a bracket x minus p bracket squared plus a q, where p and q are the coordinates of the turning point. And we have learned as well that can be expressed in the format y is equal to a bracket x minus root 1 or x1 bracket x minus root 2, where r1 and r2 are the roots of the equation. And also we have learned that if a is greater than 0 of this part, this graph will have a minimum point. And if a is less than 0, this graph will have a maximum point. So these are some of the key points that you need to take away from this. And also the other thing that we have learned is about the domain and the range. So the domain, we said x is always an element of real numbers. Then also the range, you look at your range for the y values, we check your turning point. So if you've got a graph like this, remember with a turning point, maybe let's say it's a 5 and negative 19. So for the range, you check your y value, it's negative 19, and you check the direction of the graph, it's going up. So it's in the direction y is greater than or equal to negative 19. And if the graph was a maximum graph going all the way down, you check here, let's say the turning point was 1 and 20. So in this case, your turning point is 20. So you can see the graph is going down to the less values of y. So the range in this case will be y is less than or equal to 20. And that's how you determine the domain and the range of the parabola. So I've given you a summary of the parabola in less than 20 minutes. So guys, I hope this equips you and you can attempt any kind of a question and you'll be able to answer it. So I hope to see you again in the next video where I'll be explaining other functions in less than 10 minutes, because this is the longest function that you can ever do. Okay, bye for now.